Hi everyone, welcome. My name is Ronald Prasad and I'm a Microsoft Services Principal here at Critical Start. And today we're going to be talking about our Azure Sentinel projects. The project we're going to be talking about as part of this recording is going to be our new Azure Sentinel IoT lab environment. The objective behind this project is very straightforward. We wanted to provide our customers the ability to deploy a controlled and isolated IoT lab environment, which they could use to either evaluate Azure Sentinel and Defender for IoT to see if it's a good fit for the IoT environment, or use the lab environment to perform red team, blue team type of exercises, test new IoT attacks, and use the lab environment as a continuous learning platform for the SOC team. So this is the entire lab environment. It is right now publicly accessible on our GitHub page, and this is the link to the GitHub page at the bottom of the slide. So there's a lot of components that are part of this lab environment. So what I'm going to do is break them down into individual pieces. We're going to talk about each of these components, how they relate to each other as part of this entire solution, and then help you understand how the entire lab environment works end to end. Okay. So the first thing that this particular lab environment does for you is deploys simulated IoT devices. It actually simulates all three layers a particular IoT device has, which is application layer, base OS layer, and network layer. It is simulating the application layer using a .NET Core application, which is basically sending some telemetry data to a Azure IoT Hub service. So basically, it is simulating a actual IoT device communicating on the network to a IoT service provider. In our case, it is the Azure IoT Hub. It is simulating the base OS layer by using Docker containers and NanoServer. The .NET Core application is actually installed on a NanoServer image, and then the image is running as a Docker container. So using this method, the lab environment is able to deploy multiple instances of this IoT simulated device without consuming much resources on your machine. And then the last layer here is basically what brings everything together, which is the network layer for these simulated IoT devices. So for each of these IoT devices, it actually needs to communicate to the internet, to the Azure IoT service, and each of these simulated IoT devices actually needed IP addresses that are available on the local area network in order to do that. And what the lab environment actually does, it lets you deploy a Docker transparent network, which is a component that is part of a Hyper-V instance. And then using that Docker transparent network, each of these Docker containers are actually assigned IP addresses, which are available on the local area network. So that now means that each of these Docker containers are able to communicate to the internet. They are discoverable by Defender for IoT sensors, and we can actually launch attacks against them because they are actually part of the local area network now. Okay, so as part of the lab environment, you'll require to stand up a VM, a Windows VM, which in this case is going to be your Docker host VM. The Docker host VM is going to be the VM that is going to be hosting all of your simulated IoT devices. And since it has that transparent networking enabled, it is going to be able to use the external switch that is part of the Hyper-V instance to communicate to the Azure IoT service, basically simulating a whole IoT service deployment. right? An end-to-end IoT deployment where there's a IoT service provider and some IoT devices communicating back and forth on a network. Okay. The next step in the lab environment is going to be deploying a Defender for IoT sensor on the same Hyper-V instance and on the same external switch instance, so that now Defender for IoT is able to discover all of these simulated devices and is able to do detection against any attacks launched against these simulated devices. And after that, the lab actually walks you through how you can deploy a Kali Linux VM on the same Hyper-V instance, and then deploy it as part of the same external switch. So now using that Kali Linux VM, you're able to launch actual IoT attacks against the simulated IoT devices, and then the attacks are actually discovered by Defender for IoT sensor. And then whatever Defender for IoT sensor actually detects, that is sent to Azure Sentinel by using a syslog server that you deploy in the same lab environment. So basically, this is how end to end the entire solution comes together. You actually have simulated IoT devices communicating to a actual IoT service provider, and on the same external switch or on the same network, you have Defender for IoT and a attacking VM available as well. And then you use the syslog server to sync any of the alerts detected by Defender for IoT into Azure Sentinel, so that in Azure Sentinel now you can do advanced investigation and incident response. Okay. So the lab environment is entirely virtual. It runs on a virtual Hyper-V instance, but you now our customers are going to be able to take this one step further by introducing either their own custom IoT applications to the lab environment. So basically taking their own in-house IoT applications, converting them into Docker containers, and then adding them as part of the lab environment and launching attacks against their custom applications to evaluate the effectiveness of all the security controls they have in place. Um, or they can actually introduce a new physical IoT device to the same lab environment as well. Right? Introduce a new physical IoT device, use the same lab environment, the Kali Linux VM, to actually launch IoT attacks against the physical IoT device as well. Get the alerts in Defender for IoT, get it synced in Azure Sentinel, and then use Azure Sentinel to do advanced investigation and incident response for your IoT environment. Okay. So as you can see, this particular lab environment offers a lot of value. Either if you are a brand new customer to Azure Sentinel and Azure Defender for IoT, or you're looking to invest in those products, this is going to be the perfect environment to use to evaluate those products, to see how they actually handle all the attacks that you've been seeing in your IoT environment. You can basically deploy the lab environment, deploy all of the components here, launch the IoT attacks you're most concerned about, see how Defender for IoT actually detects that, and then see the detection, the investigation capabilities in Azure Sentinel and the incident response capabilities in Azure Sentinel, and see if it's a good fit for your environment or not. And then this is also a great lab environment if you are a existing Azure Sentinel and Defender for IoT customer. You want to further refine your Azure Sentinel investment. You want to go ahead and execute new IoT attacks in this lab environment to see how or help train your SOC team to actually investigate those new IoT attack alerts in Azure Sentinel and perform incident response or build out incident response in Azure Sentinel. And this is going to be the perfect lab environment for that. So the entire lab environment basically requires all Windows components only. So basically you need to have just one physical Windows machine. It could be a Windows 10 machine, a Windows 7 machine, and on that you need to make sure that it has Hyper-V capabilities. If it does, then all you're going to need is going to be eh, deploying a few VMs on that physical machine, installing Docker for Windows, and then executing a few PowerShell scripts. The entire lab environment can be deployed within minutes. So it's going to take you about 20 minutes to deploy the entire lab environment, deploy all of these simulated devices, and start launching actual attacks against those simulated devices and investigate them in Azure Sentinel. Okay, so once again, the entire repo is available online, publicly accessible at our GitHub page, which has the all the contents you're going to need for the lab environment, and it is going to have step-by-step instructions on how to deploy the lab environment. Okay, so what I'm going to do now is going to be switching to a few demos of the actual IoT environment itself. Um, so let's jump right into it here. So this is going to be our GitHub page right here, which is hosting the Azure Sentinel Create IoT Lab repo. As you can see, it is going to have step-by-step instructions on how to deploy the entire lab environment. And then as part of the repo, you also get the zip file here, which basically is going to contain the PowerShell script that is going to deploy the simulated containers for you, and the actual .NET Core application that is going to be simulating the IoT traffic to Azure IoT Hub. Okay. So in order to get started with the lab environment, you need to go through the README documentation, which is going to help you deploy all the required VMs on your Hyper-V instance. So for example, here I have already deployed my Server 2022, which is going to be my Docker host machine. Docker host VM, and then I have a Kali Linux VM deployed. I have a Defender for IoT sensor instance deployed as well, and I have a syslog server deployed as well. Okay. So first thing I'm going to do is going to jump into my Docker host VM and launch the actual PowerShell script that is going to deploy all of the simulated IoT devices. Okay. So right now I'm inside of my Server 2022 VM, which is my Docker host VM, and I have already downloaded the zip file from the GitHub page, already extracted it, and then I have already loaded the deploy IoT simulator script in a ISC instance here. And then what I'm going to do is simply go ahead and deploy the script, right? Or execute the script, sorry. And then the first thing it's going to ask you is going to be how many of these simulated devices you want to deploy. I'm going to say 5, and there you go. It kicks off the deployment for the IoT devices. First thing is Next thing is going to ask you is going to log into your Azure environment, select your Azure subscription, and then select the actual Azure IoT instance that the .NET Core application is going to send fake telemetry data to. So I have already have a Azure IoT instance deployed, and this is the one it is in that particular resource group. So I'm going to hit OK here and select that. Um, the actual lab instructions walk you through on how to deploy the Azure IoT service as well. Okay, and then as you can see, it is deploying my first IoT device here. So basically, it is going to go ahead and create a new Azure IoT device registration in the Azure cloud. After that, it is going to go ahead and deploy the Docker container here. And then it is deploying the Docker container. And then very soon here, we're going to get the confirmation that the Docker container has been deployed. There we go. It has deployed the first container, and then it is moving on to the next container. Okay, so we'll give it a minute here to deploy all of the containers. Okay, so the deployment has just completed. As you can see, the script has finished executing, and at the end of the script, it is going to go ahead and dump out all of the Docker containers it has deployed. So all my simulated IoT devices and the actual IP addresses they have on the local network. So now if I take one of those IP addresses and I try to go ahead and do a ping to it from the local host machine. So I'm gonna go ahead and say ping 192.168.1.203, and then as you can see, that particular Docker container is actually part of the local area network. Awesome. Alrighty, so those containers are deployed. So if I go ahead and launch a PowerShell instance here and I go ahead and run Docker PS to see all of the Docker containers running on the current VM right now, as you can see, we have our all of the IoT devices right here actually running as Docker containers, right? They are actually executing the .NET Core application on it right now. So since the .NET application is actually executing. So if I pivot now into my Azure environment and go into my Azure IoT service, I should be able to refresh this right now and look at for my last 1 hour. I can come here and see total connected devices. As you can see, it is up to 6 now. 5 devices that I just deployed. Another, the 6th device is going to be the actual Defender for IoT sensor. And then as you can see, I'm actually receiving some device to cloud messages right here, right? And then if I wanted to actually see what those messages are, I can go ahead and simply launch Azure CLI. And there is a very simple CLI statement that we can run in order to now start seeing all of the telemetry data sent by the devices to the Azure IoT instance. See, looks like Azure CLI is having some issues. So I'm going to relaunch it here. Okay, there you go. Azure CLI just loaded, and then I'm going to go ahead and paste the CLI statement here. So basically, um, you'll need to plug in the actual IoT device registration that you want to monitor the telemetry for, and the actual IoT hub service name itself. And when I go ahead and execute this, I should see all of the telemetry data that my IoT device one, which is the actual Docker container, sending to the Azure IoT service. So the container actually sends telemetry once every 30 seconds. So we'll pause here for just a bit. And as you can see, that is the actual telemetry data that it is going to be sending to the Azure IoT hub instance. So it is actually producing actual IoT network traffic. Okay. So going back to the Hyper-V instance here, as you can see on the Hyper-V instance, I also have the Defender for IoT sensor deployed as well. So I should be able to pivot into the Defender for IoT portal here, and it should have already discovered all of those Docker containers as actual IoT devices in here. So now if I pivot into device map, and I can go ahead and expand my 192.168.1.0 subnet. And as you can see, so these are going to be all of the devices that Defender for IoT has discovered on this particular subnet. So if I go ahead and bring back my Docker host VM, and let me go ahead and minimize this little bit here so we can actually see the IP addresses. And then as you can see, one of the containers have got the IP address ending in 203, And as you can see, that is the actual device that Defender for IoT has discovered. Right, so that is the 203. Here is the 84 one, which is right here, right? And then the 157 should also be in here somewhere. Okay, it looks like that one has still be oh, it's right here, 157. There we go. All right, so as you can see, all of these Docker containers that are acting as simulated IoT devices are actually picked up by Defender for IoT, and it has already detected some alerts against them. So let's go and take a look at the alerts here. So if I go into the alerts column, I can see that it is saying that, hey, these are unauthorized devices on the network that are trying to make internet connectivity or actually have internet connectivity, right? So it is basically flagging those devices for me. Awesome. Now to take this demo one step further, what we're going to do is now log into the Kali Linux VM and launch actual attacks against the Docker containers that we deployed. So here in the Kali Linux VM, I'm going to go ahead and log in. Okay. And then we're just basically going to perform some simple network um, intrusion type of attacks here. So I'm going to use a tool called Legion, which is basically going to give me the ability to do some nmap scans, some port scans, etc. So some intrusive behavior on the network. And what I'm going to do, I'm just going to target the entire subnet here, 621.0 and then /24. So I'm going to now target every device on this particular subnet, and then I'm going to send the um, the performance option to insane, and I'm going to go ahead and launch that attack, right? So Kali Linux is going to be doing its thing. It's going to go ahead and run some port scans against these Docker containers, etc. The Docker containers are using the IoT protocols through WebSockets. So it's here eventually Legion is going to let me know which of those WebSockets is actually opened on those different IoT devices, etc. Okay. Okay. So as you can see, the scan is nearly halfway there. And then if I go into the Legion right here, as you can see, it is discovering those actual Docker container IP addresses, and then it is able to discover what type of services those containers are running um, right here. So we just launched the actual network attack on our simulated IoT devices. So now if I pivot back into Defender for IoT portal, as you can see, Defender for IoT has actually detected that, hey, there has been some network attacks happening, right? Some port scans here, some HTTP client error, some unauthorized internet connectivity. So as you can see, all of these are actually detected from the lab environment itself. I can see all of the different IP addresses, all the different ports being scanned. And then since I have the syslog folder deployed as well, all of these alerts should have already been synced into Azure Sentinel. So if I now pivot back into Azure Sentinel, as you can see, all of those alerts are starting to come into Azure Sentinel as well. The same alert here, right? Port scan detected. And then as you can see, the same Docker container ending with IP address 203, right? Awesome. So there you go. That is the end-to-end IoT lab environment demo. Hopefully, you can see the great value behind the IoT lab environment. It gives you ability to deploy a contained, isolated lab environment where you can basically deploy simulated IoT devices, launch actual IoT attacks against those devices which basically generates a bunch of activity on the network, which gives the vendor for IoT the opportunity to do detection using the data, generate alerts. The alerts actually get synced into Azure Sentinel, and now your SOC analysts are actually able to pivot to Azure Sentinel, investigate the alerts better, perform incident response from Azure Sentinel, perform the incident lifecycle management using Azure Sentinel. Okay, so that was the end of the recording. So if you need to contact us, if you have any questions regarding the lab environment, please, please feel free to reach us at Microsoft team at criticalstart.com. That is our primary email address for Microsoft related questions. And then also our website at www.criticalstart.com. It was a pleasure presenting our Azure Sentinel project, and that brings us to the end of this video recording. Thank you.